Good Wednesday, everybody, and welcome to another one of our virtual tours of outer space. My name is Josh. I'm part of the Morrison Planetarium team at the California Academy of Sciences. We are very excited to be beaming from our homes to yours a virtual tour of outer space. So we are looking down here in the OpenSpace software at the California Academy of Sciences. OpenSpace is a really cool planetarium software made all the cooler by the fact that you can download it at home, and with a little bit of poking, prodding, you can basically do the exact same tour I'm about to give you. For those of you who are tuning in from all over the world, we are very excited to see you. And I'd like to take a moment, since we are looking down here at the California Academy of Sciences, since this is a Trans Day of Visibility, to take a moment to shout out some of my amazing coworkers, both present and past, and friends, and compadres from museums across the globe who identify as trans, and it is so exciting to take a moment to really acknowledge them and put them in the spotlight. So with that, we are blasting off away from our very own spot here on planet Earth and looking out across San Francisco, out across the Pacific Ocean. We are in fact looking at Earth, but I'm betting you could have guessed that. So we have the entirety of outer space, I should say, the entirety of our solar system and beyond for us to check out today. If you have some place you would like us to visit, by all means, put it in the chat, and I am more than happy to take some suggestions and go visit some of these amazing places, both near and far. So zooming away from our own place in space, I'm going not too far. I want to take us to the moon. Now, when I say not too far, that's still a pretty good schlep. For most of us, if you imagine driving to the moon would take about 6 months at 60 miles an hour without a single bathroom break or rest stop or refueling, that would take you that entire time to drive the distance equivalent from Earth to the moon. You can't actually drive to the moon because the roads between here and there are very bad. But when you look down at the surface of the moon, you can see a beautiful and amazing place, a vacation destination maybe someday human beings are actually going to take. Visiting the surface of the moon would be something really cool because it is so very different from what we see here on Earth. You could call the moon sort of a terrestrial object. Looking around on here, you see rocky stuff. There are hills, there are mountains, there are valleys, sort of similar to what we see here on our own planet. However, they are formed in very different ways. Where we see valleys is likely a place where two geological features butt up against each other, not necessarily the passage of a river. But we do see some evidence of liquid having moved on the surface of the moon. However, it's probably not liquid water, like most of our rivers are here on Earth. Instead, it would be liquid rock. Rock on the moon's surface would flow like cold olive oil, about the same thickness, the same, I know some people hate this word, but viscosity. But that semi-thick liquid moving across the surface would create a path, just like a river does here on planet Earth. So looking around here, we can see some of our craters. That's a feature we also have here on Earth. A while ago, we had an expert on craters tell us all about the ones that are still visible on the surface of our planet as one of our cosmic conversations. So if you want to dive back in and check that out, you can find out about some craters we still see here on the surface of Earth. But it's a lot easier to do on the moon. Without erosional processes wiping away the surface features of the moon, we get to see its entire history laid bare. Now, sometimes we can actually see the internal parts of the moon laid bare. Check out this massive crater over here, and specifically the giant lines of material radiating out from it. That's what we would call ejecta. For those of you who remember cassette tapes or even CDs, the eject button was a great way of getting them out of the machine. Well, ejecta on the surface of the moon is stuff that was inside and has been brought out. Like an eject button on a spy car launches you out the roof. This is material from inside the moon that has been launched out onto the surface in those long lines radiating out from the center. It's material from inside the moon, that deeper history of the moon laid bare on the surface, and a prize for geological speculation. So we've actually found some really cool stuff on the moon. We've found little tiny super hard rocks that date back to the formation of the solar system. We've even found little parts of ancient Earth on the moon's surface, which is an absolutely spectacular find. We think that long ago, when Earth had less of an atmosphere, a part of the Earth got knocked into space by a giant collision and landed on the moon. And it just so happened that some of the lunar samples we brought back from the moon contained traces of our own planet Earth. And that is a spectacularly wonderful story. But given the length of time our solar system has existed, it's almost a certainty that more weird stuff like that will be found on the surfaces of other worlds once we do more exploring there. So I'm taking you down to one of my other favorite lunar features, the Reinhardt gamma. You can see its weird swirly pattern here on this dark, even surface of the moon. There's this random light patch and dark squiggles as well. This is a chaotic area, and perhaps I think the best explanation we have for exactly what's going on there is that there's a magnetic field sheltering some parts of the moon's surface and exposing others, so it's weathering from solar weather, not wind and rain, unevenly. Parts are changing differently, and that's why we see that difference in coloration. So I can and have done whole shows on the surface of the moon. If you all want to see something a little different, please let me know. Thank you to my super producer, Mary, for giving that shout out. There's lots of cool stuff to see. My brain tends to fixate on a few things, like moons, because I think moons are cool. So if there's someplace else you want to check out, I think Becky has a really cool idea. How do we actually know how old the solar system is? That's a tough question, one that we have puzzled on for a very long time. So when we had our first models of how old the solar system would be, they were heavily constrained by the age of the sun and how the sun makes energy. So with that, let's actually go look at the sun. So once upon a time, we thought the sun made heat by contracting. And as it collapsed and contracted, it would heat up, a lot like if you've ever taken a hammer to a penny. If you hit something and make it smaller, basically beat on it, compress it, it'll heat up. So when we compress something, create that heat, there's actually a huge amount of energy that radiates out, much like our sun. And this was how early scientists suspected the sun radiated heat. They didn't have the process of fusion yet. So we had these ideas about the sun being a source of energy, but a very finite one. And that would mean the sun could only have been around for a few million years. Then we found rocks on Earth that were a lot older than that, closer to 4.6 billion. So there was a big challenge between what the sun we thought was telling us and what the rocks of Earth were telling us. And it turns out the rocks of Earth were giving us the more accurate number. The sun has a completely different process for making energy, so it's actually a little older than planet Earth. We think the sun is a hair older, maybe you could call it 5 billion years. We're pretty confident on that 4.6 billion years for Earth. But not all planets are the same age. We actually think Jupiter might be slightly older based on how its orbit has changed and how it's influenced objects in the rest of the solar system. And it's made of material elements that are more closely matched to the sun than the rest of the planets. And it's the biggest. It probably had access to the biggest reservoir of material out there in space. So we got a frequently requested object, Uranus, what we like to call the seventh planet in the business. But Uranus, nonetheless, is a beautiful planet, as Paulette seems to be a big fan of it. When we go visit Uranus, Uranus, there's a lot of fun ways to say it, most of which sound pretty naughty. But when we go out there, we are seeing, first, I think the color is really what captivates most people's attention. Although I happen to come in at the perfect angle, given a random chance, to see one of its amazing dark features there. So we get this beautiful robin's egg blue, but not uniform. There's parts that are slightly yellowy or greeny. There are parts that are lighter. There are parts that are darker. There's a ton of variation in these clouds. This is a set of photographs that was taken, I believe, from Voyager and then a follow-up imaging session from Hubble, but they're pretty old, several years old. I can't show you more up-to-date photos than that because we've just never sent missions out to do the kind of imaging we've done for Jupiter and for Saturn with the Galileo and Cassini missions, respectively. It's really far out there. Once upon a time, we had planned on sending a mission, but it never quite came to fruition. I hope one day soon we get to really live up to the expectations of the New Explorer missions and send things out here so we can better understand Uranus and Neptune. And that's not just because I think Uranus is a really amazing planet with beautiful features. I think that there's also a great lesson to be learned there because we have found tons and tons of Uranus-Neptune-sized objects around other stars. They're one of the most common families of exoplanets. So if we really want to better understand those exoplanets, there is no substitute for studying the similar planet in our own solar system. It's going to be a very long time before we have telescopes that can really give us a ton of information about distant exoplanets, but we are at a point where our space missions, our space probes, including probes to Uranus, can actually give us a ton of information about what's going on there. So, while we are out here, I saw another cool question pop by. Can we see Saturn's rings? Absolutely. So let's go check out Saturn. So Saturn is a beautiful planet, and I think an absolute prize of the night sky. If you have a small telescope or are excited about getting one, everybody's got a birthday coming up at some point, right? Then looking at a world like Uranus, you might get a little bit of a color. Looking at a world like Neptune, you might get a faint bluish dot. When you look at Saturn, especially with a telescope that's 3 to 4 inches, maybe a little bigger than that, you can, maybe closer to 6 actually, now that I think about it, you can actually see the rings. And I think that is an absolutely amazing way to see it, because this is one of the few objects that really gives you a 3-dimensional understanding of exactly what's going on there. So we are seeing these delicate ring structures held in orbit around the surface of this world. From the surface of Saturn, it's so fun to imagine looking up. And I think if I do some fancy flying, we might actually be able to give that a shot. So I'm going to get us as close as we can to the surface of Saturn. And then I'm going to crane our virtual necks backwards so we can look up from the surface of Saturn out at those rings. Isn't that cool? To be able to see out from the surface of Saturn, just what that would be like to have that beautiful arc all the way across the sky. I think this is something really special and really amazing. So one day, maybe we'll have a Star Wars-esque cloud city on the surface of Saturn. That would be a really cool thing, if for no other reason than that beautiful view. Can we see Enceladus? Well, we're not that far away, John. Let's go give it a shot. So Enceladus is, maybe one of the harder moons to spell in our solar system. Certainly not the hardest. There are plenty of weirder ones out there like Iapetus. But when we get to Enceladus, at first it's going to look like a barren world that is entirely gray. That's not actually completely true. It is a very reflective world because we are seeing an icy surface, but it looked like that because I hadn't loaded up the high-resolution textures. So I think, there we go. This is some of the really good stuff. When we dive down on here, you get to see an elaborate system, almost a maze of linear features. And they often go at right angles to each other, which is something I think is absolutely fascinating. So when you look around on here, you can see some smooth bending features. You can see these strong linear features. This is a moon with a complex history. I'd love to tell you exactly why these features go in 2 directions, but I really don't know. There's a ton of complexity here on these ice moons. We actually have had speakers like Mickey come in and tell us about Europa specifically. But Enceladus, while it is similar to Europa in many ways, I don't want to necessarily conflate them 100%. They are different worlds. Enceladus, for example, is much, much smaller than Europa by a huge degree. It also has these really cool tiger stripes, and we think sort of a perpetual set of geysers continually blasting material out, which is something that we just have not seen on Europa. There might be intermittent geysers on Europa, but nothing to the extent of these warm spots or hot spots, as some folks call them. This is a really special, really wonderful place. And I think most astrobiologists would highlight it as perhaps one of the most likely spots in our solar system for life, if not the most likely, outside of Earth, because we know life exists on Earth. Them's good betting odds. Okay, backing up from Enceladus. Let's see, where are we going next? So Mars. Oh my gosh, there's cool stuff going down on Mars. Now, we actually have some discussion about a upcoming cosmic conversation where they might be going to visit Mars and seeing some really cool stuff there. I don't want to be the person who spoils some of the really cool stuff that is discussed there. I'd feel awful, especially because we are having Dr. Jen Blank potentially be our speaker, and I think she's super cool. So I'm going to keep mum about some of that stuff, but I will talk about the really basic stuff that I don't think we're in any danger of her covering. You may have heard about the news, the little probe they brought with them, the copter. Oh, I just took us to the moon. I clicked the wrong button. I thought Mars looked unusually gray. So the copter, Ingenuity, has been detached from the base of our rover, and we are hopefully going to have our first flight on the Martian surface in the not too distant future. I think they said between the 8th and the 10th That's going to be super awesome. Mary coming in with the Star Wars one-liners. Classy. So looking around down here, we can see some really awesome stuff on the surface of Mars. Valles Marineris is coming in. Olympus Mons, we've talked a lot about them. Jezero is where we actually have this spacecraft, I shouldn't say spacecraft, lander rover, moving around on the surface of Mars, exploring a wonderful geologically rich area. I could do you the disservice of trying to explain exactly what amazing science is happening there, but I would suggest tuning into some of our recent Cosmic Conversations, which really spent a lot of time focusing on the details of the Martian surface. Basically, we really want to unearth the history of Jezero and understand how this seemingly water-rich feature, something that looks exactly like it was sculpted by water, came to be. We now know that water flowed on the surface of Mars at one point. We are now trying to understand its longevity. We're trying to understand its chemical complexity. We're really trying to come to grips with not that there was water, but what was the water like and how long did it exist? So that, I would say, is as much the mission of Perseverance as anything else. Plus, Jezero Crater looks super cool. Okay, backing up. My favorite moon one last time. Well, I would say that my favorite moon today is a classic. I would say it is our moon. We spend a lot of time talking about moons of other planets, and sometimes our own beautiful moon gets swept under the rug. I just had a good time looking out at it for the past few days, and I would encourage all of you to do the same. I believe we are just now, according to my dog walk this morning, at a waning gibbous would be my best guess for our moon phase. And if you wake up early, or you've got a dog that wakes you up early, this is a great time to go outside and look at it, because we do get to see that wonderful shape from our spot on Earth. So, moon stuff, now that we're back here, we spent a little bit of time here earlier. I'm going to take us down to the South Pole, and I'm going to see if I can bring in, that data set I don't think is loaded up. But down here, look at this. So one of the really cool things I don't often use for OpenSpace is the ability to change time. So I'm going to go in and I'm going to crank us forward by, let's say, a month. A month is significant because that's the amount of time it takes about for the moon to go all the way around the Earth. So when I do that, you might notice that we had light from the sun go all the way around the surface of the moon. Let's try that one more time. Now, if you look carefully, there's some areas down here right on the surface of the moon that never really turned bright, especially right here at the pole. If I go one more month, again, you'll notice that some of these places stayed dark, especially spots at the bottom of craters. It turns out every month, not just the specific months I chose, that's the case. As the moon travels around Earth, these places are just completely recessed, completely safe from light from the sun. So I could go forward by years, I could go forward by decades, and we would still see that light had never really gone down into those dark spots. So we actually think there might be some ice left over from the beginning of our solar system down there inside those dark craters at the north and south poles of the moon. And that's one of the upcoming missions from NASA. Viper is designed to go and look for it, do some prospecting. We had a question come in from Paulette, I think, who's given me a softball. Is there a dark side of the moon, or is it all dark? There is a dark side of the moon. It's a great album. I recommend listening to it, especially if you've got Wizard of Oz on VHS. It is a wonderful experience. But as for the moon, there is no dark side of our moon, because light from our sun is the source of illumination, and as the moon spins around Earth, every part of it gets exposed to an equal amount of light. However, there is a near side and a far side. So if I do away with our dark side completely, inside our OpenSpace software, there's a fun box I can check called Perform Shading, and that just takes away all the shadows on whatever object we're looking at. When you look at this side of the moon, you can pick out a few of the features you might see if you are a moon watcher like I am. You can see there's a person's face with long dark hair. There's one bun, another bun, and sort of a ponytail right here, an eyeball, a nose, a smiling mouth, and a chin. That's a pretty good face to see. You can also see one big eyeball, another big eyeball, kind of a panicked looking mouth, and a nose right here, kind of Charlie Brown looking. That's the classic man in the moon many people discuss, but it's basically just like a cartoon smiley face. My favorite from a coworker thing is a T-Rex riding a bicycle about to get hit by an asteroid. So you can see the T-Rex's upper jaw and eyeball right here. You can see the lower jaw. There's the body. There's the teeny little arms. Oh, I realized you can't see my mouse. Oops. Let me try that one more time. There we go. So let's see. Lady's face, guy's face, the smiley, or the man in the moon. And then T-Rex, there's the upper jaw. Here's the lower jaw. Here's the body. There's the teeny tiny little arm. There's his wheel of his tricycle. And up here is the asteroid that's about to hit him. So when you look at the moon like that, I will admit, once you see that, it is really hard to not see any of those features on the moon. They just kind of jump out at you. The humans are so good at figuring out patterns where there is no pattern. But then if I fly us over to the far side, what some people like to call the dark side of the moon, you can see whenever it's facing the sun, it gets just as much light as the other parts. This part looks completely different. We just don't have those same dark features to make our fun images from. Those are called the mare, or the oceans of the moon. You can see one unfortunate kind of crack on our full moon, and that right here is actually where the image that we use as the texture doesn't match up perfectly. Turns out getting a rectangle to map onto a sphere is a very tricky thing to do for a computer. So if I had to volunteer a dark part of the moon, again, it would be these north and south poles, because even with our best images, we never get light all the way down into them because our sun just doesn't shine there. We've never sent a giant floodlight to the moon to try and illuminate them so we could see. So those parts of the moon, even though we know exactly where they are, and we've even taken some height measurements of them, we've never really seen them in the visible part of the electromagnetic spectrum. Okay, backing up a little bit more. Let's see, I think we have time for maybe one more object. Anything else suggested? Oh, a question for Jupiter. I will always take a Jupiter request. Let's go visit Jupiter. So taking us out there, when we get to Jupiter, this is the current focus of the Juno mission. Juno is studying the atmosphere of Jupiter, which is always kind of a funny thing to put forward, because some might argue that Jupiter doesn't really have an atmosphere. It has an outer layer. Its outer layer is gaseous. Its sublayer to that is liquid, and its sublayer to that is metallic, solid. Now, that's super cool, or I should say really, really hot, because it's under a ton of compression. And again, like we mentioned at the top of the show, when you squeeze something, it actually gives off a little bit of energy. So cool thing, Jupiter is one of the only planets that actually does give off some tiny amount of electromagnetic radiation, what we would call light. However, it's not light that we see. All the light we see is reflected from the sun. But if you look in thermal, infrared wavelengths, Jupiter does glow pretty brightly in the not too far from visible infrared. Technically, anything that has a temperature gives off some infrared, but Jupiter's actually making a little bit of that light, which is cool because it squeezes so hard. So we have a question about Juno is Jupiter's wife in mythology. Absolutely the case. And someone phrased quite delicately why we were sending Juno to Jupiter. Jupiter has a lot of secrets hidden underneath its clouds. And historically, Jupiter, the god, had used clouds to conceal things, to hide things away from his wife Juno. But Juno could always see through Jupiter's tricks and figure out what exactly was going on, much to Jupiter or Zeus's lack of enjoyment. So here's to Juno teaching us a lot about what's going on beneath Jupiter's concealing layers. It's an exciting mission, and one we've gotten some beautiful images back from. Does the light get to the surface through the gas layers of Jupiter and Saturn? So, Fidel, it almost certainly gets through the outer parts. As to getting to the absolute center of the planet, almost certainly no. And how far down it penetrates, like how many layers does it get through, is a giant question that the Juno mission, amongst others, is trying to answer. We know it gets through some of the outer layers, but we know it doesn't get all the way down to the depths. But how light photochemistry interacts with the surface of gaseous and ice giants is something that is still remarkably poorly understood in modern astronomy, an outstanding question, and one that I know a lot of research is being focused on in the coming years. So that, I think, is such a cool open part of astronomy and a great indicator of just how many mysteries are out there waiting for us to solve. So with that, I'm going to take us back on a long, meandering, slow flight to Earth, because I would like to thank all of you for having watched this presentation and all of our broadcast presentations. This is actually my last broadcast show for Morrison, and something that I'm really excited to send out to all of you. I'd like to thank all of you for watching. Having an audience over quarantine has made it a lot easier for me. I love giving shows like this, and reaching out to an audience, even virtually, has been such a big deal for me. So this is an exciting time for me. I'm moving on to other opportunities, but next week we are going to continue our virtual tutors of outer space. You're going to be in the hands of our wonderful senior director, that is Ryan Wyatt, and he is going to be taking you out. And I'm really excited to actually be joining you on the other side of the screen. So I will be in the comments heckling as best I can and submitting snarky questions just like you. So thank you all so much for giving us this opportunity. If you want to check out shows like this in your own home and share them with your families, by all means do so. We've got a link to where you can download the OpenSpace at the OpenSpaceProject.com. We also have a survey we would love for you to fill out to let us know if you've enjoyed these projects or these presentations, and what your feelings are on the OpenSpace project. But from the absolute bottom of my heart, I want to thank you for tuning in. Astronomy is a powerful subject and something that is so good at bringing people together. I would like to challenge all of you to, with software like this or something else, remind yourself that there's a bigger, wonderful universe out there. Our world has a lot of stuff going on. And I think it becomes really easy to forget that there's more stuff out there. There's a sky behind the sky we see. So with that, thank you all. Have a wonderful rest of your day.